Assalamualaikum warahmatullahi wabarakatuh. Good day everyone. Today our group will discuss about advertising alternative for advertisement for maximum audience coverage. Our group members are Nurul Safikah binti Saad, Dianur Utami, and Yona Ayu Dewani.
Assalamualaikum warahmatullahi wabarakatuh, and a very good evening to our lecturer. Today our group are going to present about the advertising alternative for advertisement for maximum audience coverage. This is the example of problem regarding the advertisement. The advertising alternative for a company include television, newspaper, and radio advertisement. The cost for each medium with their audience coverage is given below. Cost per advertisement for the television, newspaper, and radio are 2,000, 600, and 300 respectively, while audience per advertisement is 100,000, 40,000, and 18,000 respectively. The local newspaper limits the number of advertisements from a single company to 10. Moreover, in order to balance the advertising among the three types of media, no more than half of the total number of advertisements should occur on the radio, and at least 10% should occur on television. The weekly advertising budget is $18,200. How many advertisements should be run in each of the three types of media to maximize the total audience? In order to solve this linear programming problem, we need to formulate the LP model. And in order to formulate the LP model, the first one, we need to identify the decision variables for this problem. In this problem, we must select X1, X2, and X3 to represent the total number of X for television, newspaper, and radio, respectively. And for the step 2, we need to state the objective function for this problem. The objective of the company is to maximize the audience. So the objective function given is max z is equal to 100,000 x1 plus 40,000 x2 and 18,000 x3. And for the step 3, we must write down all the constraints in this problem. For the first constraint, it is clearly given that we have a budget constraint. The total budget which can be allocated in is $18,200, and the individual cost per television, newspaper, and radio advertisement is $2,000, $600, and $300 respectively. This is the first constraint in this problem. For the second constraint, for a newspaper advertisement, there is an upper cap on the number of advertisements to 10. This is the second constraint. X2 is less or equal to 10. The next constraint is the number of advertisements on television. The company wants at least 10% of the total advertisement to be on television, so it can be represented as X1 is greater or equal to 0.10, X1 in bracket X1 plus X2 plus X3. So this is the third constraint. And for the fourth constraint, the number of advertisements on the radio cannot be more than half of the total number of advertisements. So it can be represented as X3 is greater or equal to 0.5 X1 plus X2 plus X3. This is the fourth constraint. We need to put all the decision variables on the left side and the coefficient on the right side. So for the third constraint and fourth constraint, we have simplified them. So for the third constraint, the new equation is negative 9x1 plus x2 plus x3 is less or equal to 0. And for the fourth constraint, negative x1 minus x2 plus x3 is less or equal to 0. So we have 4 constraints overall. Thus, the formulated LP model in this problem is max Z is equal to 100,000 S1 plus 40,000 S2 plus 18,000 S3, subject to 2,000 S1 plus 600 S2 plus 300 S3 plus S1 is less or equal to 18,200. X2 plus X2 plus S2 is less or equal to 10. Negative 9x1 plus x2 plus x3 plus s3 is less or equal to 0. Negative x1 minus x2 plus s3 plus s4 is less or equal to 0. And for this problem, there are upper bound, which is x1, x2, x3 is greater or equal to 0. Next, we must solve the problem by using the solver. Actually, there are 2 ways to solve the LP problem, by using the Lindo software or by using the Excel solver in the Microsoft Excel 4. But our group chose to solve it by using the Lindo software. So for the step 1, open the Lindo software. The Lindo software will pop up in your desktop like this. Next, for the step 2, you must click on the File button on the left hand corner and click on the New. Another tab will appear on the Lindo software. Step 3, write the formulated LP model on the tab Objective Function. All constraints and lower bound or upper bound are written in each row. Step 4, click on the Solve button and click on Solve again. Step 5, the system will ask whether to do range sensitivity analysis or not. Click on the Yes button. Okay, for this part, you can choose whether to click on the Yes or No button, but our group choose to click on the Yes button. So for the last step, the system will solve the LP model for you. The Lindo output will appear as below. So when you using the Lindo software, it will give you the output like this. The solution for this problem, x1 is equal to 4, x2 is equal to 10, and x3 is equal to 14. The objective function value is 1,052,000. Thus, in order to maximize the total audience, the company should have 4 advertisements from the television, 10 advertisements from the newspaper, and 14 advertisements from the radio to obtain the maximum of 1,052,000 audience.
The next topic is talking about the sensitivity analysis. The first one, when there are changes on the right-hand side. For the case 1, suppose that the weekly advertising budget is $22,000. Calculate the new optimum objective value. So the first thing that we have to do is calculating the changes. The changes will be 22,000 minus 18,200, and then the result will be 3,800. And then look at the Lindo output part, right hand side ranges. It is shown at row 2 that the available increase is infinity. Hence, the current basis remains visible. To calculate the new optimum solution, we need to look back at Lindo output part 12 prices. Look at row 2. Hence, we have 51.304348. So, the new optimal value will be 1,052,000 plus 3,800 times 51.304348. Hence, the new optimal value is 1246956. Thus, if the company changes the weekly advertising budget to $22,000, the company will get 1 to 4, 6, 9, 5, 6 audiences. For the case 2, determine the optimal solution if the local newspaper limits are not more than 5. So the first step that we have to do is calculating the changes. The changes will be 5 minus 10. So the result will be negative 5. And then look at the Lindo output part, right hand side ranges. It is shown at row 3 that the available decrease is 10. Hence, the current basis remains visible. To calculate the new optimal solution, we need to look back at Lindo output part dual prices. Look at row 3. Hence, we have 11,826.0896914. So the new optimal value will be 1,052,000 plus minus 5 times 11,826.0896914. Hence, the new optimal value is 9982870. Thus, if the company changes the local newspaper limits are not more than 5, the company will get 9982870 audiences. For the second one, when there are changes in the objective function coefficient. For case 1, if the audiences of radio increase to 15,000, what would be the new solution to the problem? So we have the changes is 15,000. After that, look at the Lindo output part objective coefficient ranges. It is shown at variable x3 that the available increase is 20,000. Hence, the current basis remains optimal. So, the new optimal value will be 1,052,000 plus 15,000 times 14. So we will get the new optimal value is 1,262,000. Thus, if the audiences of radio increase to 15,000, the company will get 1,262,000 audiences. For case 2, if the audiences of newspaper is decreased to 20,000, what would be the new solution to the problem? So we have the changes is 20,000, and then look at the Lindo output part objective coefficient ranges. It is shown at variable x2 that the available decrease is 11,826.0896914. Hence, the current basis not in range. So, the additional calculation will be needed to find the new solution.